Hey, my dear students, today we shall be going into linear inequalities. Specific objectives. At the end of the lesson, the students should be able to solve problems on inequalities in one variable, then represent inequalities on number lines, and state the range of values of numbers using inequalities. Revision of linear inequalities in one variable. The statement revision of linear inequalities here means that the students may have had the initial knowledge of what inequalities are all about. Whichever one, inequality means not equal to or not necessarily equal to. Here, we mean that in comparing two or more persons or other objects, either one is better than the other, or they are almost the same, or they are exactly equal to each other or one another. In the case of equality of objects, we are talking about equations, meaning that one is equal to the other. But when equality does not hold, we will be talking about inequalities. In mathematics, inequalities have some symbols used in the representation of values. They are, look at this, less than, look at this, greater than, look at this, less than or equal to, look at this, greater than or equal to. You can call this one strictly less than, and this one strictly greater than. Okay. When we say x is greater than 4, it means that all possible values of x are each greater than 4. Hence, if x is a whole number, then the smallest possible value of x is 5. Who is doing that? Do you understand me? Don't mind those people making noise. So when we say x is greater than 4, it means we are talking about all numbers greater than 4. If we consider only whole numbers, then those numbers should be 5, 6, 7 down the line. Then if we say s is greater than or equal to 4, then in this case 4 is included in the system. Look at it. S greater than or equal to 4 includes 4. But when we say s is greater than 4, 4 is not included in the system. So x can never be equal to 4. But in this second place, s can be equal to 4. We mean that although x is greater than 4, yet x is also equal to 4. That's the meaning of the statement. Then solving inequality problems in one variable. Just like equations in one variable, problems on inequalities in one variable can also be solved and almost in the same way as we do in equations. But the only difference being that while we use signs of equality in equations, the sign of equality in inequalities, we use signs of inequalities. And be careful not to change sign of inequalities to equality. Example says, solve for s in each of the following inequalities. It is as good as saying, find the range of values of s in each of the following. Remember, we are to solve for s here, but in the last question, I included m there to let you know that everything about equations and inequalities are not necessarily talking about x. S can be anything, any number, and some other letters from the English alphabet can be used. That's why in the last one, we decided to use m instead of x, though we are solving for x. But we just want to let you know that everything in equations and inequalities must not be x. So, understand it. The first one says 2x plus 7 is greater than 15. The second one, 3x minus 5 is less than 40. And the third one and the fourth one, they are following. So we solve. How do we do it? Solve exactly the way you solve equations, but be careful not to change inequality to equality. So we are given 2x plus 7 to be greater than 15. What we need to do is to subtract 7 from both sides. Some people will say when 7 goes across the sign of equality or inequality, it will change to negative because it was positive. But the right thing to say is subtracting 7 from both sides, because in solving a system of equations or inequalities, I think words and opposite will always help us. We do the opposite of what we want to remove. So 15 minus 7 is 8. We are now left with 2x being greater than 8, so that when we divide both sides by 2, we get that x is greater than 4. In the second inequality, we are given 3x minus 5 to be less than 40. What do? The opposite of minus 5 is plus 5. So we add 5 to both sides to get 3x to be less than 40 plus 5, showing that 3x is less than 45. How do we handle this? We divide both sides by 3 to get x to be less than 15. Can we continue? Yes, sir. You said yes. I can hear you say yes, sir. So let's go on. Number 3. It says 8 minus 4x is greater than or equal to 50. Be careful here. There is a very good message that is coming up here. Remember, in solving a system of equations or inequalities, the variables, the x, y, or z, or whatsoever, is always positioned on the left-hand side, while the constants are taken to the right-hand side. That's why x is supposed to maintain this side, while this 8 is supposed to get away. This 8 is not 8 minus, it is not minus 8, it is actually plus 8. So, how do we handle this? To remove it, we subtract 8 from both sides of the inequality in order to get minus 4x, because this negative belongs to this 4x. We get minus 4x is greater than or equal to 50 minus 8, which at the end we are left with minus 4x is greater than or equal to 42. We are going to divide by the coefficient of x, which is minus 4. But there's one good thing about inequalities. Immediately a negative sign is dividing both sides of the inequality, the sign of inequality reverses. So here it is greater than or equal to, here it is going to turn to less than or equal to. So what do we do? Dividing both sides by minus 4, we will get this greater than or equal to now turns to less than or equal to, and x becomes less than or equal to 21 over minus 2 when we divide 42 and 4 by 2 respectively. So finally, we get our x to be less than or equal to 10 whole number 1 over 2, which can also be written as 10.5. Over to this. Remember, we are supposed to have x here, but I intentionally changed it to m, not because I am very correct or too right, that I am right to do it like that. I just want to let you know that it must not be x. It can be any other number. Any other variable. A can be there, B can be there, C can be there, down to Z, but the thing must be in small letter. That is lowercase. Now we are given 5m plus 3 to be less than or equal to 22. What's the opposite of plus 3? It is minus 3. So we subtract 3 from both sides to get 5m to be less than or equal to 19. And when we divide through by 5, we get m to be less than or equal to 3 whole number 4 over 5. Do you think we still have other things to learn in inequalities? Let's check. This one says more problems. It says find the range of values of s for which the following inequalities hold true. Here we have gone into our textbook, New Further Mathematics textbook, 5th edition, that of SS1, written by T.R Moses. The question reads, I read, the first one, 3x plus 5 is less than or equal to 15 minus 2x. Remember I said that the rule of operation here is that the variables maintain the left-hand side while the constants maintain the right-hand side, provided there is a single sign of inequality there. Some other questions contained therein are the second one, the third one, and the fourth one. But there's something unique about the third one. There are two signs of inequality there. Don't be afraid. Don't panic. When we get to the river, we will cross the bridge, and you will see that the journey is going to be very smooth. So, follow us as we are moving. To solve the first one, having written the question as it is given, remember what I said, variables to the left-hand side, so there is negative 2x here, which is minus 2x. How do we do in order to cancel it? We add 2x to both sides, and that's what has happened here. The consequence is that this particular plus 5 has to be settled by subtracting 5 from both sides, and when we subtract 5 here, nothing will remain, but there will be a subtraction of 5 here too. Some of us will say collecting like terms. You are still correct, just collect like terms. But variables on the left-hand side, constants on the right-hand side. What I mean by constants is simply numbers. They are constants because they are known. This number is 15, and there is no other 15 in the number system apart from this 15, unless you are talking about the negative of it. So at the end, we get 5x to be less than or equal to 10. And when we divide through by 5, we are getting x to be less than or equal to 2. The second one. How to handle this? 1/3 of this thing, a whole of this, simply means a whole of this divided by 3. That's why I have rewritten it in this form. And 5 simply means 5/1. An offense that I don't want you to commit in solving problems in inequalities is by saying that you want to do cross multiplication. Please don't try that. Don't do it. Don't do it. You do not do cross multiplication in inequalities because the order of operation may mistakenly be interchanged and you find it difficult to get the right answer. So what do? What you are going to do is to find the LCM of the denominators of the fraction, which is 3. Use the LCM to multiply everywhere. Multiply the left-hand side, multiply the right-hand side. What do you get? 3 multiplying, 3 multiplying. But here 3 will cancel 3. You are left with 2x minus 1, which is this. 3 multiplying 5 is 15, and we see that 2x minus 1 is less than 15. Adding 1 to both sides will give us 2x to be less than 16, and when we divide through by 2, we get x to be less than 8. Are you okay? Then we carry on. The third one. There is nothing difficult in the third one. Nothing. The only difficult thing is you deciding to concentrate. Listen to me and see how to handle it. Are you ready? Now, I've told you 4 simply means 4/1, and 1/3 of this means a whole of this over 3, while 5 is 5/1. Now check the LCM of 3, 1, and 3. 1, 3, and 1. The LCM is 3. So use 3 to multiply here, and multiply here, which will give you a whole of this. But 3 will cancel 3. You are left with 2x minus 1. And 3 multiplying 4 is 12, while 3 multiplying 5 is 15. But any quantity divided by 1 is equal to itself. Therefore, we have 12 less than or equal to 2x minus 1 less than 15. What do? In a situation like this, the variable is allowed to maintain the central position. As a result, anything that is disturbing the variable from standing at the center position should be removed. What is the first thing disturbing it? It is -1. So when we add 1 here, it will clear it. Therefore, add 1 to everywhere. We are this, add 1, this, add 1, this, add 1. Then 12 changes to 13, 15 changes to 16, and -1 will change to 0 because -1 plus 1 is 0. We are now left with 13 less than or equal to 2x less than 16. Then divide through by the coefficient of the x, which is 2, to get that 6.5 is less than or equal to x less than 8. You can write this 6.5, but this is the range of values. It means x ranges from 6.5 included to 8, but 8 is not included, so very close to 8. The fourth one. The fourth one is as good as the second one. So a whole of this should read 3 multiplying this all over this 4. That's what I have here. Y4 is 4 over 1. 3 over 8 is there. 1 is 1 over 1. So that we can take the LCM of the denominator. The LCM of the denominator, I think, is 8 if you do it well the way you know how to do LCM. Can you do it? Okay, you said yes, sir. I do it. Then the LCM is 8. Use that 8 to multiply here, 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 and here, which is what we have done here. And when you are done, 8 multiplying 4 is 32, but this 4 will divide 8 to get 2. 2 will multiply 3 to get 6. And we are left with x plus 2 inside the bracket, and 8 dividing 8 is 1. So left with 3 multiplying s, which is 3s, while 8 multiplying 1 is 8. Open the bracket. 6 multiplying x is 6x, and 6 multiplying 2 is 12. Then remember what I said. Collect variables to the left hand side, constants to the right hand side. So that 6x minus 3x will be here by subtracting 3x from both sides. 8 is already on the right hand side. 12 has to go to the right hand side by subtraction. 32 has to go to the right hand side by subtraction. Then 6x minus 3x is 3x. 8 minus 12 is minus 4. Minus 4 minus 32 is minus 36. Because when you are owing 4 and you are having 30 and you are owing another 32, you will be owing 36. Finally, we divide both sides by 3 to get x is less than or equal to 12. Okay, in inequalities, there is what we call number line. We say representation of inequalities on number line. The following inequalities can be represented on number line as follows. These are the inequalities given to you, and we want to represent them on number line. We go on. This x is less than 2. Just draw a line, write numbers under the line, but make sure the number given in the inequality stands at the center or in the middle of some numbers. So immediately you achieve that, on top of the number mentioned, draw a stroke, put a circular object there. If this is strict inequality, the circle has to be open. But if it is inclusive inequality, which contains a sign of equality, you are going to shade this place. Then it said less than, it means s can be anything less than 2, which means from 2 downwards, backwards to anything that is smaller than 2. Likewise, since s is greater than 4, we stand on 4 and do the same thing, but go towards all numbers that are bigger than 4. Next one, x is less than or equal to 7. So we stand on 7 and go towards any number that is less than 7, but because there is equal to here, we come back and shade this particular circle and it becomes very dark. to show that 7 is a member of the numbers we are talking about. That is also true here. We are going to stand on -5 and go towards the right where we locate all numbers that are greater than or equal to 5. We say greater than 5 because we are moving away from 5 towards numbers that are bigger. We say equal to because the sign of equality is contained there, and then we shade the circle as a consequence of the inclusion of sign of equality in this inequality. Do you understand me? There is a sign of equality here, which means s can be -5, but can still be greater than -5. We carry on. Range of values. We say the range of values of a variable is the limit within which such variable can take values. The range can be finite or infinite. Finite means something that is limited. Infinite means something that is unlimited. Mathematically, a finite range is called a bounded range. Bounded range. But infinite range is called unbounded range. Now, the bounded range itself can be open, closed, or clopen. The word clopen means it is both closed and open. I will show you the meaning. If x is greater than 4, s can be any number bigger than 4, and which can also include infinity. As a result, we don't know where x is ending, but we know where it is starting. As a result, this inequality is called infinite inequality. The same reason makes this one infinite inequality. That same reason makes this infinite inequality. The first 4, 1, 2, 3, 4, are infinite inequalities because they have beginning but they don't have end. Then the fifth one, which starts from 2 and ends as 13 and does not include 2, neither does it include 13, says 2 is less than x, x less than 13. It means that 2 is smaller than the number we are talking about, but the number we are talking about is less than 13. If you understand it, it means it starts from somewhere around 2 and ends somewhere around 13. Starting from around 2 and ending, starting somewhere around 2 and ending somewhere around 13. So we mean there is a limit. So because there is a limit, we call it finite inequality. That is also true about the 6th, the 7th, and the 8th one. But you can see there are some little differences here. Here strictly less than, strictly less than, here strictly less than, but there's less than or equal to here. Here means this is the left side, this is the right side. This is called open range. It is open because there is no inclusion of equality here, no inclusion of, to be closed means to contain equality in ordinary sense. So this is left open and right open. This is left open and right closed. This is left closed and right open, and this is left closed and right closed. Left closed, right closed. Left closed, right open. Left open, right closed. Left open, right open. So left open and right open means open range. But once there is an inclusion of both open and closed, whether left or right, open and closed, whether left or right, such system is called a half-open range or a half-closed range, otherwise known as clopen range of values. Clopen what? Clopen range of values or clopen sets, because each of them is a set. The last one is closed on both sides, so it is actually called the closed range. Now, 5, 6, 7, 8, the last 4, they are all called the bounded sets, bounded range of inequality, or range of values of x. So they can be represented on the number line like this. You have known how to do the first, second, third, and the fourth. Now the fifth one says start from 2 but don't cross 13, or start from 13 but don't cross 2. The circles on the top are open because there is no sign of equality here and here. But here, the circle here is open and here is closed because here is closed and here is open. Therefore, open this and close this. Still on 2 and 13. Here, this is closed, therefore close here. This is open, open here. Here, closed, close here, closed, close here. This is the only one that is a closed range. Clopen, clopen, open. We continue. Now, having come to the end of what we have for you today, I want you to do something. Your work. See what you are going to do. You are going to go through anything around you. Ask people around you. Ask anybody. Don't underrate anybody. Even your parents know this more than we do. Ask them. Ask anybody. Your brothers, your sisters, friends, even some enemies that are close to you, are free to ask them. It doesn't matter. Feel free and get what you want. What you are going to do for us is state the differences that as much as you can, the differences between representation of inequalities in number line, on number line, and then the Cartesian graph of inequalities. The difference between, or the differences between the number line representation of inequalities and then the Cartesian graph of inequalities. After stating the differences, you are free to give 2 examples of each. That is, giving inequalities represented in number line and representing them in Cartesian graph, or on Cartesian graph, I mean. So diagrammatically, I need to see your answers. Get down the diagram. When you are done, you know where to submit. Don't worry, I will mark all your words, but I can see SS1 students don't like submitting the assignments to our Google Classroom. I don't know what they are doing with those things. Please do your work and submit to me. Thank you.